The water is at your ankles before you hear it. A river that had a name and a path has become something formless, swallowing its own banks, moving through the camp at knee height and rising. No levee, no emergency service, no number to call. The only people who know you exist are standing in the same cold brown water, and every one of them is looking at you. So how did Stone Age humans survive this? Not once, not by luck, but generation after generation, in a world where a flood erased everything and nothing was coming to replace it. This was not a rare catastrophe. This was the season, a recurring consequence of living near the water that kept them alive. The first answer most people assume is mobility. Just move, pick up and go. And yes, early humans were mobile, but the picture of Stone Age people as endlessly drifting nomads has been quietly dismantled over the past 3 decades. In 1999, archaeologist Nigel Goring-Morris, working at the site of Ohallo II on the shore of the Sea of Galilee in northern Israel, documented a settlement dated to approximately 23,000 years ago that showed the same site occupied repeatedly across multiple seasons. 6 brush huts, a hearth, a grave, nearly 100,000 plant remains, suggesting a detailed location-specific knowledge of what grew where and when. These were not wanderers passing through. They had somewhere they returned to. The flood risk at Ohallo II was not theoretical. The site itself was eventually submerged, preserved precisely because it sank beneath the lake. The people who built it knew exactly how close to the water they were living, and they chose it anyway. That choice required a plan. The plan was elevation mapping without a map. Modern analysis of dozens of Stone Age settlement sites, conducted by researchers including those working with the British Museum's Paleolithic collections and published across the journal Quaternary Science Reviews, reveals a consistent pattern. Camps were positioned at specific distances from water sources, on natural terraces or ridgelines that placed them above observed floodlines, but close enough to fish and draw water year-round. Not random campsites. Engineered positions selected and reselected across generations, because they worked. The knowledge of which hillside to use, which slope drained fast, which hollow flooded in weeks 3 and 4 of a wet season. That knowledge was the survival tool, not a physical object. It couldn't be washed away. Here's where it gets strange. Everyone assumes the biggest flood threats killed the most people through drowning. The archaeological evidence points somewhere else entirely. Secondary starvation and disease, starting 3 to 12 weeks after a major flood event, were the real killers. Floodwater contaminates food caches. It destroys stored nuts, seeds, dried meat, every calorie that a BAMP had spent months accumulating. The water recedes in days. The consequences last for months. This means Stone Age flood survival was less about the moment of crisis, and more about what happened before and after it. In 2018, researchers at the Max Planck Institute for Evolutionary Anthropology in Leipzig, analyzing isotopic data from Mesolithic skeletal remains found across northern Europe, identified consistent patterns of seasonal nutritional stress in populations living near major river systems. Stress markers that spiked not in winter, as expected, but in late spring, precisely when annual snowmelt floods would have destroyed food stores built up over the preceding months. The bone chemistry was telling the same story across sites separated by hundreds of miles. These people were not being killed by the water. They were being killed by the weeks that followed. The response to that was distribution, not stockpiling in one location, splitting resources across multiple cache sites at different elevations, so that a single flood event couldn't wipe the entire reserve. Archaeologists have found grouped cache pits at Mesolithic sites in southern Scandinavia, spaced hundreds of meters apart on the same slope, clearly positioned to ensure that any single inundation event could not reach all of them at once. 3 caches, 3 hills. Lose one, survive on 2. This wasn't accident, this was insurance logic, built into the physical landscape 10,000 years before the concept of insurance was invented. So what does the physical body tell us that the sites can't? Quite a lot, it turns out. Osteological analysis, the reading of old bones, has shown that Stone Age populations living in flood-prone river valleys had measurably higher rates of musculoskeletal stress markers in their lower limbs compared to inland populations of the same period. Work published in the Journal of Human Evolution, or comparable cross-population biomechanical study comparing femur and tibia robusticity across Mesolithic European populations, found that river valley individuals showed bone loading patterns consistent with prolonged wading and load carrying through water and uneven saturated terrain. The bones of people who survived floods looked different from the bones of people who didn't have to. Not from genetics, from use. From doing it repeatedly, starting young, building a body calibrated to the specific physical demands of the environment they knew they would face. This is a category of preparation that has no modern equivalent. There is no app for it, no drill. You either grew up wading flooded ground with weight on your back, or you didn't, and your body either knew how to handle it or it didn't. The training program was the childhood, but the deepest mechanism wasn't physical. It was social. Everyone assumes that primitive survival was primarily about individual skill. The best hunter, the strongest climber, the fastest runner. The flood record dismantles that entirely. A single individual or a single nuclear family cannot distribute food caches across 3 hills evacuate dependents and elderly members, maintain awareness of river behavior across multiple seasons, and rebuild shelter and fire after a flood, simultaneously in under 10 minutes of warning time. The social unit was the tool. Robin Dunbar, the British anthropologist and evolutionary psychologist, proposed in 1992, based on comparative analysis of primate neocortex size and group size across 38 primate genera, that early humans maintained social networks of approximately 150 individuals, close enough to coordinate, small enough to trust. That number, now known as Dunbar's number, has been contested and refined over the decades, but the underlying mechanism holds. The specific size of a cognitively manageable trust network turns out to be approximately the minimum size needed to manage a coordinated flood response, simultaneous evacuation, resource distribution, and shelter reconstruction, without a chain of command or written instructions. The community was not a nice thing to have. It was a hydraulic engineering solution made of people. The water is still rising, ankle to knee, knee toward waist. The people who survived Stone Age floods did not survive because they were stronger or faster or braver than the water. They survived because they had already answered this question before it was asked. In the position of their camp, in the distribution of their food, in the bone density of their legs, in the number of people who would still be standing next to them when the worst of it arrived. Most of what protected them was invisible. It was knowledge, encoded not in writing but in landscape choice and muscle memory. And the simple fact of still being together. What floods take in minutes, only networks rebuild. And the people who understood that earliest were the ones whose descendants are still here to forget it.